My name is Tony Morris, and thanks for having me here in India. This is my first time in India, and I'm having a great time. Thanks for having me. Oh, it's gone off the side. So basically, I live just off the bottom of this slide here, in a place called Brisbane, Australia, and yeah, I came here 3 days ago. So again, thanks for having me. Yeah, I'm not sure that resolution is going to work, but anyway, I work at the Queensland Functional Programming Lab. We are a government-funded, so I work for the CSIRO, which is a federal-funded research organisation, and Queensland Government, which is the state I live in, they fund a functional programming lab, and we produce open-source software and to promote functional programming. So some people often complain to me that how do I get my colleagues to use functional programming and so on. And I assure you, you can do it. You can even get your government to pay for it, okay? It can be done. You've just got to fight really hard, but it can be done. So this talks about aviation. So why aviation? So the real reason is I like choosing industries in which I can have an impact. I just see low-hanging fruit, all right? So my house is near this airport. It's called Archfield Airport. My house is just over here somewhere. And when I was riding home, I used to see this all the time. And there's me. Not really. Didn't get a haircut by the aeroplane. That's someone else. And so I typed into Google, hey, teach me how to fly an aeroplane at Archfield Airport. And my wife, she said this. How much does that cost? And aviation's expensive. So I won the argument. I just did that. It's like, yes, I win. And so I'm currently studying. Yeah, this slide has gone off the bottom here. There's 4 levels. I've recently passed a written exam for this level here, and I'm still studying for that one. So I'll tell you my experience about programming in that domain, just knowing that that's my knowledge at this point in time. So in Australia, it's federally regulated by an organisation called CASA, and we get services like weather and so on from Air Services Australia. And we don't want this to happen. In Australia, there are 3 different railway gauge widths. Okay, you cannot get a train from, well, you can actually, but you've got to change trains from Sydney to Brisbane. You've got to go along one of the railways and then switch to the other one. All right, this sort of stuff goes on. There's three of them. So we have international organisations in aviation that make sure, we don't want to fly from India to Brisbane and it's like, oh, we turn left and we turn right, bang. We don't want this to happen, right? So these two organisations look after that, and they make sure we all agree on what the rules are around the world. So just so you know, India is, just like Australia, one of 191 signatories to the ICAO, and one of the governing councils, just like Australia is. So we have very similar aviation laws, Australia and India. So in Australia, we have what's called the Civil Aviation Act and the Civil Aviation Safety Regulation and Civil Aviation Orders. So they inform us, pilots, of the laws that we must abide by in our operations in the air. And we also have advisories. So it's recommended you do certain things is in that category. So I'm going to talk about logbooks for a minute. It's quite a small, low-hanging fruit that I saw immediately when I started learning to fly aeroplanes. So this is the actual law. Basically, it says I have to keep a logbook by law, and if someone walks up to me and says, show me your logbook, I must be able to produce it. That's what that says, and a lot more other stuff, but basically that. This is a paper logbook. So you write down the aircraft and so on, how long you were flying for, and this is an obvious question. Can I have an electronic logbook? And the answer in Australia is yes, you can. So again, it's gone off the bottom. Sorry about that. But it basically says you can keep an electronic logbook as long as if you're audited, you can produce a paper copy. That's the law. Okay, so I can do whatever I want as long as I abide by that law. So, of course, this results in the pilot logbook cottage industry. So if you go on the internet, right, you'll see this question. Many thousands of times you'll see this question. So this guy here is a CPL, that's of those licenses, and he's saying, hey, I'm on a budget. What's everyone using? And someone might say Excel. Excel's always the top answer. Use Excel. Or use a Google spreadsheet, because that's just the same as Excel, but it's on the internet. Or just use this proprietary one. You've got to pay $100 a month or something, I don't know. And so these are the kinds of comments you get. Use this proprietary one here. Or I hate this one. Don't use that one. Or sometimes I cross the date line, and then it stops working. So, uh-oh, where's my logbook gone? I put it into the software and the software broke. It's gone. So this happens quite a lot. So I make the argument that if you are a responsible pilot, you must use Haskell to do logbooks. My argument is that a logbook is an algebraic data type. How do you express those? You use Haskell, clearly. And we use really good functions for querying logbooks. So I'm going to show you some of the queries that I've had to do before. And of course, I need to meet this requirement for printing it out. So I write it in Haskell, and then I just say, I got ordered to make a PDF or something like that. So this is some real code that I had to write once. Basically, I had to turn the uppercase of all the people in my logbook, like including flight instructors, to uppercase. I don't know why. Someone said you have to. So I did. I said, no worries. Here's the function. So this uses lenses to go into the surname of the logbook of the person who owns the logbook into the logbook itself and turn them all into uppercase. That's handy. And this one shows me all aircraft. This is a list of aircraft. Get all the aircraft. They want to see all the aircraft that I have flown before. Someone wanted to know that one day. So I wrote that function. And find, so aircraft have registration numbers. So find the first flight that I've had in that aircraft. So someone asked me about that. There was a reason I need to talk about what my first flight in that aircraft was. So I just wrote the lens and I said, there you go. And total day hours. So there's a difference between day and night flying. So total day hours as in command of the aircraft. When you have with an instructor, you are not in command of the aircraft. So while I'm in command of the aircraft, how many day hours have I done? Again, lenses. So actually, this is an isomorphism. So I'm kind of, part of this talk actually assumes you know how good lenses are, all right? So if you've not used lenses before, it is how we manipulate immutable data structures, particularly in Haskell. Okay, so you can imagine this great big logbook data type, and I need to navigate down and do certain things, do reads and writes and so on, and we use lenses for that in Haskell. So these are examples of lenses. This is an isomorphism, so there's that one. And basically, these operations work on the lenses. So I just glue all these functions together, and they become first class. I can do whatever I want with them. And then sometimes I need to pretty print. Okay, oh, I do it in HTML, right? So CASA comes along and says, show me your logbook. And I say, no problem. There you go. And I send it to the printer. Every airport has a printer. Many printers, actually. So basically, one of my goals is to be able to query the logbook in the most obtuse way that I possibly can think of. Okay? So I set myself this goal, all right? Immediately, I can't use Excel. I can't use Google spreadsheets. In fact, I can't use any of those things. I must use Haskell. All right, so I just set up this silly thing. If the day of the month is a multiple of 7, and that's an airport there, YSCN in Australia, and so on. Obviously, you can read that, but it's an obtuse example. And basically, I want to set the following challenge, is that you can come up to me right now and say, here's a really bizarre thing I need you to write about your logbook. And I was like, yeah, no worries. Glue some functions together, and there you go. That was my goal. So, and however obtuse you give it to me, that's proportional to the effort, right? So if you just say a simple thing, here's the simple function, here's the obtuse thing, well, I've just got to glue a few more things together. Because the alternative, these are things that happen to logbooks, okay? So if you go into the back of an airport one day, if you go into like a flight operator somewhere, you will see people with their flight instructor uniforms on, with a pencil against a computer monitor doing this, counting something. I don't know what it is. They're counting something. And I'm like, man, just use Haskell. It can count too. So a lot of flight training is your ability to actually move a pencil down a monitor without making a mistake. Okay, so count all the aircraft that you flew on a Tuesday. So you list them all, and you go, right, that was a Tuesday. And at the end, if you get the right answer, you get your license. No, I'm exaggerating, but a bit of it is like that. Okay, and I like to call this flesh computing. All right, so you see them there with the flight instructors there, and they're little computers counting. Flesh computing. Very error prone, right? So very, very error prone. Like, fortunately, if you get it wrong on the ground, it's okay. Hopefully, actually. For most things, like, you don't want to calculate fuel like that, let's say. But some things it's okay. But there's a lot of pride taken in aviation in the ability to do a computer's job, and I find that obscene. Just saying. So that was pretty easy, right? My logbook's in Haskell. I could show it to you. If Casa walked in the door, there you go. That's fine. People always walk up to me and they say, "Oh, how do you do your logbook? I've got paper this thick. I need to convert it to electronics. Like, here's Haskell," and their mind explodes and then they go and use Excel. But it would be cool if I could show them how to use Haskell. I've got one flight instructor that I've almost got using Haskell, working on it. So another subject I want to talk about is aeronautical data information, and I have not looked up the laws in India, but I'm going to guess that they're roughly the same as this. Okay, so the Civil Aviation Safety Regulations, Section 175 is all about aeronautical information service providing. Okay, so just providing certain information like maps and weather and so on. And basically there's a law for me as the pilot that says I have to carry appropriate maps for my flight operation. Okay, so if I'm flying to India, I have to have a proper map of all the different things, airspace related things in India. Not that I've ever flown to India. I don't think I'd make it. I'd hit the water. I'd run out of petrol. But anyway, so this is a visual terminal chart for Brisbane. It looks quite innocent there, doesn't it? But down the bottom of this slide that's gone off the bottom here, it actually says that it's 1 meter by 500 millimeters wide. And can you imagine opening that in the cockpit? No one opens it in the cockpit. In fact, I saw a photo yesterday on the internet of someone in a Boeing 737 who was using it as a sunshade. That's no joke. If you go onto the aviation forums where everyone's sort of joking around, there's a picture there. It's like, this is what they're for. There's a pilot there. He's a bit sunny. He's put his map up on the windscreen. So what really happens is, I can actually see that there's Brisbane, city of Brisbane here. This is the Brisbane airport. What really happens is on the ground I work out where I'm going to go, and I fold the map appropriately. All right, that's actually what happens. Okay, so if I'm flying from here to here, these creases are the correct ones. Okay, and you don't want to get too close because I might have to divert or something. So maybe I'll put a margin in there just to be safe. That happens. All right, bearing that in mind. So they're required. And clearly, I can't unfold out this great big map. So actually, what I do is I memorize them. Okay, I memorize. Those circles back there, by the way, were these are airspace boundaries. All right. So at certain heights, and if I go in there, Brisbane Airport rings me up on the radio and says, "Oi, you're not meant to be there." All right. So I have to memorize them and don't screw it up. Don't want to bump into the, holidays into Brisbane. Whoops, can't happen. All right. So do these maps exist in electronic format? Yes, but you must use one of the approved ones. You must use one of the approved aeronautical data providers for the electronic maps. And in Australia, there's only 2 providers, 2 companies who make a lot of money. So let's use them. But they're the authoritative source. The paper maps are where these electronic maps come from. Okay, so this is not one of those. It's of a different one. It's in the USA, this one. But basically, you fly across JPEG files. It's the same thing. It's a JPEG file, and you fly across it. And you go, what's that bit? I don't know. It's a JPEG file. And they don't georectify, all right? So you know about map projections and so on. You sort of get these ones going on. That could be 2 miles or something. I don't know. So you have to work this out. In fact, I do have a map. I didn't bring it with me, but I do have a map that is sticky taped together along this line. And I did that. I'm not joking. So basically, it's gone off the end here. But Here, so my house here, I live here in Bellbird Park, wherever that is, somewhere around here. There it is. And this here is the RAF base in Amberley. That's the Royal Australian Air Force. And so that's quite a big Air Force base in Australia, in Brisbane. And this is the Greenbank Army Range here. So this is the military in Australia. And there's Archfield Airport. Okay, that's where I do my training. Okay, bear that in mind. All right, because don't want to make a mistake with these maps. Because here's the actual map, and this line is the Amberley Military Controlled Airspace. Do not cross that line between surface to 8,500 feet. There's a few little footnotes that you actually can over Amberley. There's a few you actually can for certain reasons. However, there's Greenbank Army Range, and this is called an RA3. That's the highest level of restricted airspace in Australia, from the surface to 2,000 feet. So what happens if I did? What happens if I just sort of take off, go through there? Do they stand there and shoot me out of the sky? No, this is what happens. This is in the aeronautical service provider, is I get intercepted by a fighter jet, and I really don't want that to happen. And there's all these things I have to know. It's like if they wag their wings, I have to follow them, and because they can't contact me on the radio and so on. So this is if I screw up with my paper map that I didn't fold correctly. That's what's going to happen. Now the truth is, I went to an air show at Amberley Air Force Base, and there was a guy there, and I said, "Hey, what are you doing here?" Like he's got his Air Force uniform on. He goes, "My job here is to teach pilots not to incurse on our military airspace." Oh, okay, that's a cool job. And I said, "Look, if I do one day, are you really going to send a fighter jet up there? I mean, I'm going to crap myself, you know? Are you really going to do that?" He goes, "No, we found that when we did that, the aeroplane fell out of the sky because the pilot got so scared. We don't do that anymore." So now I don't know what happens. He didn't actually tell me what does happen, so hopefully I don't do that. I'll fold my map studiously every day. So there is an alternative, which is to use non-certified aeronautical data, and then you have restrictions on what you can do. Okay, so I'm operating under CASA laws, all those aviation laws. I can have restrictions and do something else instead. However, this makes me a bit annoyed, this one. This is an aircraft. It's a small aircraft registered in New Zealand. That's what that ZK means. And this here is controlled flight into terrain. So that means that the aircraft did not lose control, but it collided with terrain. Why did it collide with terrain? That seems silly. Controlled flight, so it's not like, you know, the engine cut out or anything like that. It's just bang into the terrain. Why? Well, this aircraft was flying VFR and IMC, and VFR and IMC is a very dangerous condition. In fact, there is one study on VFR and IMC by CASA, like in the world, one study by CASA, and that study was, what is the average time to your death if you fly VFR and IMC? And the answer is 178 seconds. I'm not joking. Just if you type that into Google right now, 178 seconds, I think you'll find that study. So this pilot was flying VFR and IMC, which is, in order to get your license, you have to execute a maneuver to exit out of IMC under VFR. So I had to do that to get my license. So the instructor said, "Hey, put a blindfold on, you can't see, pretend you're in IMC, get out of it." But this pilot sustained it. He was feeling very confident that day, that pilot. So that was the main factor. VFR, so VFR means visual flight rules, and when you're flying VFR, that means you must maintain a visual reference to, you must maintain a visual reference usually to the ground, unless you're on top of cloud, then there's other restrictions, but you must maintain visual reference. And IMC means instrument meteorological conditions, so that is the conditions that we are in, the meteorological conditions are such that we should be using instruments, so not visual. So you can only enter that if you're flying IFR, so if you're flying under instrument flight rules. So when you take off from Bangalore Airport, you'll be flying IFR. All right, so I don't fly IFR. So that's, you know, when you take off and you enter into cloud, they're flying IFR, that's cool. But this guy was not, he was flying VFR. And not only that, to fly IFR, that's an entire rating on your license. I don't have that rating. You have to do a lot of training to do that. And your aircraft must have certain additional equipment on board, which it did not. Okay, so all the ones that you guys travel in, don't worry about it. They've got the equipment. Those pilots are trained to fly IFR. But this guy was not, and neither was the aircraft equipped. So actually, is this going to work? Yes. Okay, so I have a question. This is from the accident report from this aircraft. And basically, my question to you is, this aircraft is heading toward high terrain. What's its height? Does anyone know? For those of you at the back, it's down here, sorry. So this aircraft is heading towards terrain, high terrain. These points mean like a peak on a mountain or something. And what's its height? 1,717. This here is the height of the aircraft above the sea level. So he's 3,500 feet. This is actually an error. So the map data had an error in it. He is not 409 feet above the ground. You see those two maps joining? That's a 3. Okay? It was found that the map did not display the 3 correctly. So he can't see. He's looking at his avionics, thinks it's a 1. Bang. Come on, we're programmers, we can do better than that. There's a 3. Okay, so that was a fatal accident. Yeah, these two things. Yeah. It's true, yeah. So I sympathise with regulators of aviation where they don't want to have any old person making aeronautical maps. That would be bad, okay? However, I think we as programmers can do better than that. Although this pilot was doing dangerous things, VFR and IMC, and you're not meant to, it's illegal to do that. There's a law that says definitely do that, don't do that. And he's relying on his map because he's feeling overconfident. So this happens occasionally, but even so, I think we can do better, us programmers. And I'm working on that problem. So stay tuned. Don't hit the mountain. Okay, so I'll talk about something called weight and balance. So this is a problem I have solved. So just a few principles on weight and balance. I put that there because I'm trying to convince my boss to buy me an aeroplane. But it's not going to happen. So basically, this here is the center of gravity of the aircraft, and this is the center of lift. So that's where the lift is provided on the aircraft here. There's also a down force on here that provides stability. So there's an upwards and a downwards force, and there's the center of gravity. And that applies to every aeroplane, including an A380 if you've ever been in one. Sometimes the center of lift is called the center of pressure, and center of gravity is forward of the center of pressure. There's a down force on the tailplane there. And that's how an aeroplane stays in the sky, essentially. So clearly, right, so if we look at this, if I put a lot of weight here, the aeroplane's going to pitch up. And that would be bad. We need this center of gravity in the right spot. So that's called balance. And also, we just need to care about our overall weight so that we can even just get off the ground, right? So we need the lift to overcome the weight to get off the ground. So balance is ensuring that CG is positioned such that we can control, right? So if we go up and we try to go down, if the CG is behind us, it won't go down. It'll just fall out of the sky. So we have to, every time I do a flight, I have to calculate the weight and balance. And to do that, you take, so in my aircraft, it's 4-seat aircraft. You have the front row and the rear row. You have two baggage rows, fuel and oil, and the actual aircraft. You have these parameters to work with to calculate weight and balance. And basically, each of these has an arm. So that's a distance from the center of gravity. And then you multiply the weight by the arm. And that will give you, the moment. That will give you the arm. All right, so this will have a moment. The front seat passengers will sit, some number of inches from the center of gravity. And then I'll multiply that by the moment, and I'll get the arm. Every time I ask someone, at least in Australia, how heavy they are, they'll say something kilograms, right? That's what I say. Unfortunately, my aeroplane's in pounds, so I have to convert. How many errors occur because of that? Lots. You can guess. All right, so, and then you add them all up. So you multiply them all and you add them all up, and then now you've got the total moment, and you've also got the total weight, because you just add all the weights up. So, and then you plot that on this graph, which is, so this here is the weight. So let's imagine all the weight landed at 2,400, and down here's the moment. And we found the moment, and it sort of falls in here, and we can go flying. We're within this envelope. We can go flying. Over here, we're out of balance. Up here, we're above the takeoff weight, and so on. So that would be bad if we got it wrong. Hey, well, let's go flying. Oh, whoops. Go to take off and didn't get off the runway. Hit the trees at the end. This happens. They do all this work. You have to do this to get examined on it. And then suddenly someone just converted pounds to kilograms the wrong way, like reciprocated or something. Happens all the time. So I did it in Haskell, clearly. So this happened. This actually has happened to me. Is you get your front row passengers and you get your rear row passengers. They have different weights, and or the aircraft itself has different weights. And they said, "Oh, we've just changed your aircraft." Now, when I do weight and balance, I usually do it the day before I go flying. I have no stress. I'm sitting there at home, work it all out, double check it. And now I'm about to take off, and they say that. It's like, now I have to do it all over again. That sucks. Jessica once said, "Can I sit in the front?" Jessica is not very heavy compared to the person who sits in the front. Now I have to do it all over again. But this is what really happens. I'll tell you what really happens. They go, Jessica, she doesn't weigh that much less than Bob. It'll be right. And then we swap seats. That's what actually happens. So we can do it in Haskell, actually. Of course we can. And Jessica is a function argument. She can sit wherever she likes. I'll just apply a function to her. And so is the aircraft. They're also arguments. And there's a package called diagrams written in Haskell that produces diagrams like PDF files and so on, vector diagrams using Haskell. So here is the result. This is a result of a real flight. So this is the output of diagrams. This line here is maximum fuel, and that's empty fuel. That's usable fuel. So there's a little bit of fuel that you've got to have in your tank for usability. And this is the amount that was in the aeroplane at the time. All right, so you can see that I could fill the tank up and I can burn all the fuel and I won't fall out of the envelope. All right, so basically I just wrote the parameters and I said in Haskell, and I just ran the main function, and this popped out. Okay, so I have much more confidence in my calculation, and also it does all the unit conversions. So they're also revision controlled. So if I get audited and this happens, so Castle walks up and says, "Hey, where's your weight and balance?" I say, "Stand by, it's in Haskell." I'll just break out my laptop, hand them a PDF, and I publish it as a library, right? So then I can give you all these functions, and you can calculate weight and balance for any aircraft that you like. And when you go and fly in the big expensive airplanes, they've already got that done. Not in Haskell, I'm sure. Probably in some $200,000 C function, right? That's been audited over and over and probably won't break. Yeah, it's been, you run tests a billion times and then you build up confidence, and then there's like some edge case and you go, "Oh no, all that confidence." I imagine that's what it is. So, and also I can go back to my weight and balance. So people who do it on paper, they tend to do the weight and balance, put it in their pocket, go flying, and then throw it in the bin, right? I don't. I've got it in Git. It's in Haskell. So this is the real code. I screenshotted my code. So there's me, there's George, there's Jessica, that's my son there, there's Paul. So this is an aircraft here, Lima Sierra Echo. That's called the basic empty weight. The basic empty weight of that aircraft is 1,691.6 pounds. And of course, people give me their weight in their kilograms. And this is a particular flight that I conducted on the 2nd of January 2017. There's me in the left seat, George in the right seat, Jessica, no one else. It was just 3 of us. I put 40 US gallons of fuel on board, of Avgas 100LL. That's the type of fuel. They all have different weights. And 10 kilograms of baggage. And there's 2 baggage compartments, so there was nothing in the other one. And out comes that diagram. I feel less stressed now. I'm sure I'm not going to hit the trees at the end of the runway. I'm using Haskell. All right, so one last thing I want to talk about is ADS-B. Okay, so what's ADS-B? ADS-B is on board certainly all IFR aircraft in Australia as of 2017, and probably India as well. So when you take off from Bangalore Airport, that aircraft will be broadcasting over ADS-B. And it's broadcasting certain things such as the latitude, longitude, the track, the altitude, whether it's climbing or descending, any emergency indicators, and so on. So there's a bunch of parameters in this radio signal that are broadcast over ADS-B. So I don't know if you have this problem in India, but we have this problem in Australia of people flying their drones near the airport. Yeah. Okay, and the problem with that is there's two ways that people on the ground can see aircraft. One is by ADS-B, the aircraft is telling you where it is, and the other one is by radar. So it's going up and hitting the aircraft and getting a signal back. And the problem with these drones is they do neither. Okay, they don't have ADS-B on board, and there's quite often you can't pick them up with radar. They're too small. All right, so this is creating quite a problem, and it's being proposed that ADS-B is on board these drones to help this problem. There's all sorts of solutions being proposed. I like the solution, just don't be an idiot. Don't fly near the airport. Doesn't seem to work. So, what's ADS-B? So there's a few things going off the bottom here. So all airframes have an international identifier. The call sign, position, the accuracy of the GPS on board, and just many parameters come on an ADS-B signal. And we can receive them. It's on that frequency there, 1090 megahertz, with a software digital radar. So I'll just show you a picture of one of those. It's done using that hardware there. And by the way, what about this, right? So the way traffic collision works, like automated traffic collision, is there's two aircraft. They're both broadcasting their ADS-B. One sees the other one. The computer says, if you don't do something, you're going to crash. So it gives them a warning, and then they both turn and don't crash. All right? So if I wanted to be an idiot, I would go and spoof ADS-B. All right? So I'll go and stand here at the bottom of Bangalore Airport, and I go, I'm going to put an aeroplane right there. I'll spoof it and watch and, giggle to myself. Haha. All right? So it has been simulated. It has been demonstrated that it could be done. All right? There's no security in it at all. Yeah. Don't give them any ideas, I guess. But I don't know of any incident of it actually occurring, but it can be done. So this is just a picture of a device, and by the way, that device is sitting just over there behind the curtain. I'm glad nobody found it, but it is there. And it's got these two aerials on here picking up 1090 megahertz. There's the tuners and the antenna. There it is at my house with a Haskell sticker on there, making sure my neighbours know what I'm doing. I'm writing Haskell. Picking up some aeroplanes with Haskell. It's got an accelerometer on board, and you can't, it's gone off the screen there, but basically there it is at my house. This is a display of what's going on. And there it is picking up some aeroplanes, okay? So I wish you could see that, but basically that's the entire record of everything that comes from the traffic. All right, so any traffic picked up by those aerials goes into this record. So I get all of these things. That's the tail number, the emitter category. Emitter category is what weight category the aircraft is for separation. So heavy aircraft, and I'm in my Cessna. If I come along right behind that aircraft, these kicked up all this weight turbulence, and I go upside down. I go, hey, don't be so heavy. No, I can't do that. Basically, you get separation so that doesn't occur. And actually, that's my responsibility. So the way it really works is I see that there's an A380 in front of me, and I must take appropriate action. So that's the law. So you get many things from this radio signal. And also, on board that device is its situation. So its attitude reference, so pitch, roll, and yaw from the accelerometer, the GPS, and so on. So this is real Haskell code that I've written to interface with this device. And my goal of doing this was to demonstrate that I could write the software with it's about $200 worth of hardware, not very expensive, and I can carry it with me, and it can SSH home and say what I'm doing. All right, so I'm flying along. I roll the aircraft. It connects to my server at home. over SSH and says the aircraft just turned left. All right? So if I go missing, they just go and look in my server logs. They know where I went. All right, and it was just a prototype idea. It's like, can I do this really cheaply? All right, so if you ever look into the cost of avionics, all right, you'll find that 1 0 is for the hardware, and then you put about 3 zeros on the end for the certification. All right? So you'll go and you'll see like a $10,000 computer. You go, oh, that's about 10,000. And then you'll go, but it's certified. It's 10 million straight away. All right? So I don't have faith in certified hardware or software. I believe in types. Okay? So the idea of someone sitting there going through a test plan, ticking boxes, gives me no confidence. And it shows. I get in some aeroplanes and there's an avionics. And I turn it on and then it crashes. And then I turn it off. And then I go flying. Happens all the time. Of course it crashes. It's certified. It's a C program. All right. So let's write some code. All right. So basically, this code here is a bit of Haskell code that's going to interface with that device. I don't know if there's any aeroplanes nearby. We'll find out. It has a range, because it's only seeing one side of the building. I've found it has a range of about 15 to 20 nautical miles. So if there is an aeroplane nearby, we'll find it. So basically, I'm using lenses again. I'm going to ask for these parameters off the device, and then just print them out. All right, and it's in a do expression. Of course, if you know Haskell, I/O goes into do expressions. And does it in a loop, so it just sits there doing it, right? So what we're going to do, so demo 1, we're going to get the situation. So that's not traffic, that's just, that's the current, oh no, that's the aircraft. Okay, so there is an aircraft nearby. And you can see that it's heading at 233 degrees. Oh no, sorry, no, that is the device. That is the device. That device is currently facing 233 degrees over there somewhere. And has no roll. That's because I must have put it very level. And so on. So that's not very interesting, really. Its altitude is 2,900 feet. There you go. I'm not sure if that's correct. But let's have a look at some traffic. So that's on demo 2. And there you go. There is some aircraft that it's picking up live. And you can see the latitude, longitude scrolling by there. I can see, I think, 2 aircraft coming past there. So basically it comes in pings. So every time it receives, it just prints out the aircraft. So these 2 flights, JAI 2362 and SEJ562. Is that right? Yeah. So these are 2 aeroplanes that are nearby that the aircraft are picking up. And wouldn't it be good if we could write traffic collision avoidance? Okay. So imagine old mate that's gone VFR into IMC, had this on board. He shouldn't have gone VFR into IMC, I agree. But imagine if you had this on board with terrain data, right? There's terrain data. We can download that from NASA. All right, so we know the track, we know the height, it's very reliable. Just simple things. Like this is prototypical, but with a lot more work and demonstrating that it's reliable and can give good results, I think we as programmers could improve aviation, and I'm committed to doing that in my spare time. So that's what I do, and thanks for listening. Keep riding Haskell. So are there any questions? Yeah.
We've explored the possibility of improving aviation from the perspective of a pilot, I guess the guy who's actually flying the plane.
Yes.
What do you feel about how the actual ATCs are, because their systems are, from what I have understood, pretty old.
That's right, yes.
And there are a lot of things like the way they visualize, it's all on those old,
Yeah.
the green screen, like the sonar, the radar.
Yeah, I know what you mean. Yeah, like the green screen, right?
Right.
Yeah, yeah.
And there have been cases where there was one crash in Delhi where there were 2 planes that were, so they miscalculated the rate of descent, and so they were essentially looking at a 3D problem on a 2D
Okay.
The problem was that usually you would have two dots, and there'd be one dot for a second, and because they were on different planes, they'd then pass by, and then you'd see two dots.
Ah, yeah. Yeah, the radar didn't differentiate the two.
Right.
Yeah, okay.
And there also there's a lot of manual calculations, and you've got those little penciled in slots that they put into
Yep.
track the airplanes.
Yep.
Do you think we could do that better?
Absolutely, yeah. So that's part of, like, there's an underlying argument I'm trying to make, right? So there's a counter argument to my argument, which is simply we can't go and replace these systems without really good testing, all right? So it would be bad if I went and just put this in the control tower and said, use this. And, my Haskell program added one accidentally. Or, I'm not claiming to be really reliable. But so their argument is we've been doing this for decades with our green screens, and it works out okay. Occasionally incidents like this happen, and if you look at aviation safety, it's extremely safe. But unfortunately, these things happen. And I am in the business of thinking about, well, can we do even better? All right, so like, I really enjoy how safe aviation is. Just like, I'm making fun of it a bit, but just the rigorous processes that you go through to even get a license and all these procedures, ATC's sitting there with their green screen. And the problem that we've got is, while we can sit here and show this really cheap hardware doing these simple things, we have to go through the process of certifying that and making sure it absolutely does provide an improvement, and that's a lot of money. So what we as programmers need to do is demonstrate that, yes, we can improve safety with these things. Because if I walk up to someone who's not into programming, like they're into aviation, let's say, and I try and convince them to start using what I'm talking about, they have this problem that I may make things worse. Okay, and they've got no way to judge whether or not it's better or worse. So there's a project that a friend of mine so a friend of mine actually got really so annoyed at the way aviation is regulated and so on, is that he quit his job and decided he's going to work for CASA and change it from within CASA, and he now works for CASA. And and one of his goals is to use what's called SEL4, which is a proven kernel, so an operating system that is proven correct, to write avionics systems, so perhaps ATC ground control operations, and prove it correct. The problem is the law doesn't account for that. The law just says you need to put 3 zeros on the end and get it certified, right? But if I can just say maths, right? There should be a law that just says maths, therefore yes, right? That would be a good law, because that, right? So he is working on that. The problem we've got is we do have this constant fight between, well, you have to just trust me, it's going to be better, and that's a big ask from an industry. So, yeah, help me out. Yeah, and I'm sorry to hear about incidents like that. Like I sit there and go, well, what could have gone wrong, right? Like the ATC guy, they're doing their best with their green screen, no question, and they're good at it. They're really good at it, but can we do better? Yeah. Yeah.
Most of these avionics hardware,
Yep.
sensors and equipment that you see in a cockpit,
Mm-hmm.
what language is primarily used for writing their firmware?
The ones I've seen are C and XML. C and XML for configuration. Yeah. A flight plan is in XML format. But I don't know, to be honest. I'm sure there's experts somewhere who could give a much better answer to that. Yeah. Like I'm the user of the programs more than anything. Yeah. And I put an XML flight plan into the C program.
Just from curiosity, what did you persist your logbook into?
What did I?
Yeah.
Into Git.
Which,
Git repository.
yeah. Even your data was into Git repository or?
Yeah. Which data? The logbook itself?
The logbook.
Yeah, I'll show you my logbook. This is my real logbook. So this is called a reference number, aviation reference number. 100733036 is my number. And so basically, let's talk about a flight I did recently, all right? So if you scroll right down, right down. Okay, so the last flight that I did, was last flight that I did was a no instrument flight, dual. So I did it with an instructor, and this is its name. I did it in that aircraft. There's the instructor. I did 1.9 hours. I have to keep track of landings, landings and takeoffs as well for certain currency reasons. So basically, this says I took off from Archfield Airport. I landed at Kilcoy, then I landed at Kilcoy, then I landed at Kilcoy. Oh, sorry. Yeah. So I took off from Archfield, Kilcoy, Kilcoy, Kilcoy. So I just sat there hitting the runway 3 times. Then I went back to Archfield. I did that on the 7th of November, all right, so a couple of weeks ago. And I take pictures of, so there is some necessary paperwork in aviation, right? So I'm saying it's all electronic, but it's not. You actually, I have to do, this is my navigation log, and I have to fill that out as I fly and so on. This is called a World Aeronautical Chart. I had to fill one of those out. And I had to fill out a flight notification form to services. And I took photos of these and keep them in my logbook, because one day I might care. All right? Most people throw them in the bin, right? They get out of the aeroplanes like, right, throw that in the bin. But I don't. And this is just a list of all the aviation-related entries that I've done, all the way down to that flight that I just did. All right? And that's in Git. And there's a compiler for it to HTML and whatever. Yeah, PDF. Yeah.
Does the aviation agency ever change the logging requirements or stuff that you need to log, and then how do you if that happens, how do you reconcile that with your?
Yeah. So while I've been learning, that it has not been changed. So that law, CASR 1998, was when it was last changed, and I don't think it's going to change at any time. The most recent change was about a week ago. They changed the way that weather forecasts are given. So it used to be called what's called an area forecast, and now it's a graphical area forecast. So that changes things. So things do change, but in terms of my logbook, nothing has changed. I log more than the law requires me to. I don't need to keep those pictures, but I do. Yeah, like I could probably even put the weight and balance chart there now that I think about it. But no one's going to, that doesn't happen, right? So when you get audited for weight and balance, no one's going to ask me a week later, all right, because they've thrown it in the bin by then. It's as you're walking back to the airport, like from the runway or the taxiway. Yeah. Yep.
Could you show us what this looks like? If I were to ask you to, can you show me this flight plan?
The flight plan or the logbook?
The logbook.
That I would need. Have you got the internet? Because I don't. Actually, I can. Let's give it a go. Let's try. Come on, wireless. Oh yeah, I got one of those. I just have to crank this handle. Well, maybe the compile output's already there. Let me think about it. What? Okay, I think the answer might be no, or might be yes. So this is the HTML output that includes all the metadata, right? So if I were audited, I wouldn't give them this one. I'd remove all that metadata. There's another compiler that I wrote that removes it. So this is just this is an overview, mostly of things that I need to look at real quickly. How many hours have I done in a Cessna 162 Skycatcher? Well, I've done 5.9 hours total. 0 of those were in command, so they were all with an instructor, for example. And then you can go and you can even look at my exam results if you want to go flying with me. Make sure I know what I'm doing. But yeah, it'll take a while to load up. But yeah, that's an example of an output, HTML output. Yeah.
Aren't you putting yourself at
So if I'm logging more than I'm required, what kind of mistake might I make? Like, I'm not sure of your question.
If some legal thing,
Yeah.
it's easy for them to point out fault.
Yeah, I agree. So I have this perhaps naive view, all right, and it's under test. I hope I'm right, all right, which is CASA, our regulator, so they would be the people who would care about that, is like I make every effort to ensure that my flights are legal and safe, all right, so I do everything I possibly can. And CASA takes on the attitude of they will support me in that, even if I make a mistake, an illegal mistake, all right, so you'll find that when CASA takes enforcement action against pilots, it's usually because they are deliberately negligent. Okay, so if I turn up at the airport drunk, I'll lose my license, no question. But there are so many laws, and if I make a slight mistake on one of those laws and I commit an illegal act, and CASA takes the view that they will retrain. So that means that there's a deficiency in my knowledge and actions, and they will fill in that gap to help me continue what I'm doing. So I hope that's true. It seems to be true, and I've had no problems so far. But the day I do and that stops being true, then I'll say you were right. Yeah. All right, so I'm conducting a little experiments like, yeah, well, aviation's safe. Why? It's because we don't take punitive action unless it's deliberately negligent, right? So I know not to get drunk. That's pretty straightforward. But there's certain things like you must be stabilized on a final approach before 500 feet AGL, all right? So 500 feet, I must be stabilized. What does stabilized mean? Even that's a bit iffy, right? But you can clearly see that law has been made for safety reasons, all right? So using my judgment, I go, well, I think I'm stabilized. I'm well above 500 feet. I think I'm within the parameters. But if I was deliberately negligent, so like I'm 100 feet, I'm blowing all over, I'm not even facing the runway yet, that's clearly negligence, all right? So, but the little bit of leeway in between, I think is just CASA will not take punitive action unless it's very deliberate. And that seems to be the case. Yeah, and I really support that idea.
Possible to do things like this with pilot checklists, for example, like
Yes.
pre-flight, post-flight checks.
Yes. Yes. So I have a terrible memory, and I'll tell you my worst problem that I've ever had. All right, in terms of memory is so before I take off, I have to do so many things. All right, so a lot of them I have remembered, but one of them is you set the barometric pressure on the altimeter. All right, and the idea of that is so the altimeter is a function of the barometric pressure. All right, so by law I must receive a weather report. I get the current pressure and I set it on the altimeter. And this particular aeroplane I was flying, in Australia we use hectopascals and America uses inches mercury. And this aeroplane had both, and which made the two dials very small. All right, so I believed I had set it correctly, and I'm then meant to cross-check, which I did not do. Okay, so my airport is at 65 feet above sea level, and it was indicating negative 200 feet, and I failed to notice that during all of my actions. And I had 2 passengers on board, which makes this even worse. But what happened is I took off from the runway. I did not perform the cross-check that I was meant to do. I took off. I believed I'd set it correctly. As I'm taking off, I notice that the altimeter, because as you take off, you do all sorts of things like check the altimeter, know how high you are. If there's an engine failure, what I'm going to do is a function of that altitude. So immediately I look at the altitude and decide what to do. So I'm cross-checking it the whole time, and I look and I go, what? Negative 200? What's that about? And I made the decision to continue the climb, and I reached up to pattern altitude, and I didn't say anything to my passengers at this point. I'm just like, I'm going to troubleshoot, figure out what's going on. Have I had an instrument failure? What have I done wrong? I radioed to the tower and I said, have you got me 1,000 feet, the pattern altitude? And is the barometric pressure whatever it was at the time? And they said, you've got the barometric pressure right, but you're at 1,200 feet. And I was about to terminate the flight, and I'm just like going, holy shit, what's going on? And I took my glasses off and I leaned in and I looked at the little indicator and I was off. I was off by 4 hectopascals, or 8 hectopascals. And I dialed it in correctly and it was 1,200. It's like, oh, I've fixed it. So those are the kinds of mistakes that can occur, yeah, in terms of checklists. So I find that embarrassing, but it's true. I did it. Had passengers. I told them, I said, hey, I can't count. Sorry about that, but I can fly. It's all right. But yeah, like if you look at all the other things that I could have committed an error on, so aviation safety is all about multi-factored safety. So this was clearly a risk to the flight. However, because I'd done everything else correctly, this became a small risk. You get trained on troubleshooting. I troubleshooted it. I figured out the problem, fixed it. The flight continued. Where it becomes a problem is I didn't check the engine oil. The engine fails. The altimeter's giving me the wrong reading. Like many things are going wrong all at once. That's when air accidents occur. Yeah. So that was my worst story. I said it on camera. Okay. All right. Thanks, everyone.